So today I want to show you just quickly how to actually analyze a video inside of video physics. Video physics is this little icon right down here. It is not a free one. You'll need to make sure that at least one person in your group has it. But if you open it up, you'll get a screen that looks like this. What we want to do is hit the plus sign to create a new video. You can take a video with your iPad. You can choose an existing. You can download the video that I actually have if you don't have a video shot yourself. So I'm going to say choose existing. And this is the video that I would like to use. And so you can simply say use. So download the one I have. And if you watch this real quick, you'll see that we've got a ball that launches through here. Now, before we do anything else, we want to actually set the origin and the range. The origin is this piece right here. And what we're going to do is put it on the middle of that white circle right there. And you can actually move the x-axis and the y-axis up and down. Make sure it's parallel to the floor. So if you look at that thin white line, it's going straight across. The other thing we have to do is set our scale. And to do that, you'll see these two little marks right here. To do that, we're going to drag this bottom one down to the bottom of the meter stick, all the way down to the floor. I can't see with my finger on there. And the other one to the top of the meter stick. And this is kind of critical. Get this one as accurate as you can, because without this, we're kind of stuck. Let's see, can I hide this control? No, I can't. Tell you what, I'm going to go back here again, see if I can get to it. I can't. I'm a little bit short there, but hopefully, it looks like the two ends there should be at each end of your meter stick. And I'm having difficulty trying to get down to that other part. Once you've done that, you can go to points, and you'll see this big circle here now in the middle. We're going to put that, and the origin here is that big circle there. If you simply move the target there and then tap once, it'll leave a little red mark at the origin, and then you'll see the next point. There's the ball already in the next frame. It's kind of blurred because it's moving very quickly. Try to get it towards the center of that, tap again, and then move it again to the next target. And try to do this as accurately as possible. I realize it's a little difficult with the blurring, but hopefully you can do it. And so moving along here and trying to get the center of that at each point. It is a little challenging, I realize. But the key here is trying to get it as close to the center as you can. You can go back a frame if you need to and remark it. It will automatically move the mark to the new spot. It should be easier up here. There'll be less of a blur because now it has no vertical component. And so the velocity is going to be much more reasonable. If you do need to go back, if you mismarked a frame, you can simply go down here and tap on the video, and the controls will be there. You can go back a frame and remark the ball in that frame. It'll automatically move the mark. You don't need to delete it. It automatically just shifts it to your new tab. Once you get all the balls marked, you can tap on here and you see the controls down here. But up here in the top right corner, we're going to export it. And we want to export it in the bottom one there, the graphical analysis file, the a.ambl file. And you may not see the app on there, but you can simply say open in, and you want graphical analysis. If you're sharing this data with other people in your lab group, you may have to airdrop it over to them. Graphical analysis is the free program, and I want everybody to analyze it in their own graphical analysis program. So I'm going to say graphical analysis in this point, and it should immediately, boom, bring it up. Now right now we've got 4 graphs. That's a little bit too much. So for this first part here, I'm going to just change this graph to only show the X position up here. So this is the X position versus time. And for the graph down here, tapping on that, I just want it to be the y position versus time. And you see some really nice graphs here. Now we want to add some curve fit to it. So if you click the little icon over here, graph options, you'll see apply curve fit, and we just want to apply a linear fit to this one. And if you look at this graph, it's saying, all right, in the form of y equals mx plus b, the slope is 2.93, and the y-intercept 0.03 meters. The slope in this case is the horizontal velocity, which is constant, which is what we expected in a projectile. Remember, gravity is only affecting the vertical. We're going to do the same thing with the y position down here. We're going to hit the graph options here and apply curve fit. But this time we're going to go ahead and do a quadratic. And say apply. Why? Because y actually is a quadratic equation, v0t plus 1/2 at squared. If you do that, we'll come up with this equation right here. The b term here is our initial vertical velocity, 6.244 meters per second. C is our intercept, which is 0.2316 meters, or about 2 centimeters, a little bit off. And our acceleration is negative 5.8. That's definitely a little bit off. What should it be? Well, remember the c term here is equal to 1/2 times acceleration. It's the 1/2 at squared term. Ideally, this should be negative 4.9. Why is it so large? Because I think I shortchanged my meter measurement. If you do a little bit better than I will, you'll get much, much closer. From this, then, you can finish the last part of the lab, hopefully not without a problem. You can rename this if you would like. Do a save as, and name it something you'll remember. Right now, it's stored in some bizarre area. You can store it on your iPad. Just give it some sort of nice name. And yeah, oh, that is a horrible name. Okay. Find a better name for it, and you get the idea. Good luck. Hopefully this makes sense. See you soon.